Hi guys, and welcome again to my channel. In today's video, I'm gonna start a new series in which I will be solving in each video one LeetCode problem. And now I'm gonna show you how I'm gonna explain the question for you, and we're gonna solve it together. Just to mention that LeetCode is one of the leading resources that you can use to while you're preparing for any technical interview that you might have. There are different languages supported and different topics, and I highly recommend that you guys go and start practicing over there. So in today's problem, I'm going to be solving a search question. Let me share my screen with you. Okay. All right. So today's problem is called, it's number 35, and it's search insert position. It's ranked as easy. So this ranking, guys, is very good way of categorizing the problems in when you are starting to practice for or preparing for an interview. You can move from easy, medium to hard. Don't only focus on hard questions, because most probably you are gonna get 2 medium and 1 easy question. That's usually the scenario. And maybe in rare cases, you would get a hard question and a medium question and another hard question. So try to be to span your questions from easy to medium to hard, and not only focusing on one category. All right. So today's question is called search insert position. So the question body says, giving a sorted array of distinct integers and a target value. So we have a target value and we have a sorted array. What do we mean by sorted array? We mean an array that starts from in a descending or ascending order. Usually when they say sorted array, it's usually ascending order. So it increases as we move to the right. So return the index if the target is found. If not, return the index where it would be inserted to make the order works. What do we mean by index? Index means the position that the number holds in an array. So here, guys, if you take a look at this array, we have 1, 3, 5, 6 elements in it. The value is 1. The index is 0. Here, the value is 3. The index is 1. Here, the value is 5. The index is 2. So indexing starts from 0. Index means the position, so the location where the element is. So not arrays can hold any values. They can have numbers, they can hold strings, whatever. And the values, the type of them is different than the index. The index is the location, and it's usually from 0. If the index starts from 1, the question would specify so, or the domain would say, oh, the indexing starts from 1. But in most and 99% of the time, it starts from 0. So the question wants us to return the index of the target if it's found. If not, return the location it would be in if it was to be inserted. All right, let's take a look at the example they gave us. So our array called nums, it has these values. The target is 5. We would go over the array, and when we find the 5, we would return the index that 5 was found at. So 0, 1, 2. The index is 2. The location that 5 was found at is 2. Over here, the array holds 1, 3, 5, 6. The target is 2. We would go over the array looking for the target, which is 2. We didn't find 2, but we want to see where it would be inserted such that the array remains sorted. So 0 holds the value 1, 2 holds the value 3. 2 falls below than 3 and bigger than 1. So it should be inserted between the 1 and the 3. And this way, when we shift one position to the right, the index that 2 would be inserted at is 1. Okay? This index previously hold which value? It holds the 3. All right, the third example they gave us 1, 3, 5, and 6. The target is 7. 7 is not here. Okay, so where would we add it? 7 is bigger than all elements and it's bigger than the 6. So we would insert it after the 6. Which index it would be after the 6? So 0, 1, 2, 3, it would be index 4. Okay, so here they give us some constraints saying that the number should be a real value bigger than 1, and it should be ascending order, and it should be distinct value. So we will not have any duplicates inside this array. Okay, so how would we solve this question, guys? First of all, we would need 2 pointers. One at the beginning of the array and one at the end of it. We would call it as left, and right. The left pointer would hold which value? The index where for 0. So the left pointer would be pointing to the 1 element, but it would be at index 0. The right pointer would be at the end of the array, right? Which would be which index? So guys, how would I know how many elements is inside my array? I would use something called len, which is the len method, and I would pass my array in it, and then what? This would return for me what, guys? It would return for me 4. Okay, so the result for this method call would be 4. However, the index is what? Is 4 minus 1. Why? Because we're starting from 0. So 0, 1, 2, 3. So the right index would be minus 1. Okay, now what would I do? I'm trying to go over the array such that I will be looking for my target. Okay, so while, that's how we would iterate, while my left is less than or equal to my right, okay, what would I do? I would be looking for the target. Now, how would I know where is where is my target? Either I would do the brute force way, I would be checking every single element of the array, or I would be using binary search, which means that since the array is sorted, I would be starting from the middle. Okay, when we start from the middle, guys, because I know any element in the array, anything on the left of it is less than it, and anything on the right of it is bigger than it because it's sorted. So we have to specify a third pointer called the middle index, and this pointer would be the middle, so it would be left plus right minus left over 2. Okay, now in order to avoid fractions, we would do like this in Python, and this way we would get like a full number. Okay, so like the middle point here would be 0 left 0 plus 3 over 2. All right, now if target, now what would be checking? We would be checking the middle element. So if target equals to the middle element, this is, guys, basically binary search question. If it's equal to the element at the middle index, we would just simply return the middle index. يعني if we find the element at the middle point, then we're done. Like we found our target. We already found the target, so we return the index that it was found at. This is the scenario here. We found the 5, okay, and the 5 is in the middle. So we return 2 and that's it. Now, the other scenario, if what? If the target is less than the middle point. So if target is less than the middle point, then what would I do, guys? So if I know that my target is in the left section of the array, okay, if in the left section of the array, which pointer I should move, the right or the left pointer? So here, I know the 2 is in this section. It's not here. Does it make sense to keep going over the whole array? Like here, it's a simple example. We have only 4 elements, but when we have like 100 elements in the array, would it make sense to go all over n when we could go over n over 2? So we would move which pointer? We would move the right pointer. So instead of having the right pointer pointing at the 6, we would have the right pointer pointing at the 3. So right equals middle minus 1. Now, if the element is not less than the middle point, it's bigger, and it's not equal, so we would move which pointer? We would move the left pointer. So instead of having the left pointer pointing at the 1, we would have been pointed at the 5. So else left equals to middle plus 1. The reason why I am adding 1 and subtracting 1 is because we already checked the middle point. So we want to check the next one to it or the one before it. So it doesn't make sense to stay at the point. This way we're not moving anywhere. Okay? Now, if it's after we check all the if and else, if we didn't find our element, which index we should return, guys? So here, we didn't find the element 7. We want to insert it and we didn't find it. We want to look for it and we didn't find it. Which index we should return that the 7 would hold if it was to be added over here? Now, take a look at the while here. The while left is less than right. So the moment the left becomes bigger than the right, because here we're adding to the left and subtracting from the right, the moment the left becomes bigger than the right, this is when my loop breaks and stops iterating. So this is when I am exiting the loop, and that's the index. The moment I exit the loop, the index at the left is the one that I should be returning. So return left. So basically, I start with 2 pointers. I go over the left less than the right, and then I calculate the middle index. Here, just simply to get a full number, not a fraction. And then I check if the target is equal the middle. If not, if it's occurs in the left section, or if it occurs in the right section. Okay, so the left section, which is the less, the right section, which is the bigger. And then after I finish with the loop, I exit. And just 1 second. And if we run the code, we have the final result. So if we input 1, 3, 5, 6, and if we want to look for the 5, the index would be 2. Okay, that's the index that the 5 is at. Okay. This is it for today, guys. This is an easy problem. In next videos, I'm going to be going over medium and harder problems. I would be shuffling all around these types. And I recommend you create an account on LeetCode and you practice yourself. Thank you very much for watching. Make sure to subscribe and like this video if you want to keep getting notified about my new videos. All right, thank you and have a good day.